Okay, a vector is represented by an arrow, and the vector v would be written like this, v with an arrow on top. Sometimes you'll see in the book where it's just bolded, but you can't tell if I'm bolding it or not, so I'm putting the arrow on top. Vectors have both a magnitude, that's like a size, and a direction, and that would be given by its angle. We can add vectors. So if I have one vector here, it goes like this, if this is v, and I have another vector here, u, and I want to add them, I could add, to u I could add v, I would go in the same direction, and there would be v, and then my addition would be u plus v. So I can add them just like this. Sometimes a vector has no magnitude. We call that the zero vector. Okay. So it also doesn't have any direction because all it is a dot. If I have the vector that looks like this, it's like negative v. It has the same magnitude as v, but it's the opposite direction. So my negative v might look like that. Same magnitude, opposite direction. If I add v and negative v, I get the zero vector. And if I was to add, if I was to say I had v minus w, that's the same as adding v and negative w. I can multiply my vectors by a scalar. So a scalar is a number. It has magnitude and no direction. And so if I have my scalar a and I multiplied it by v, it would just be increasing my v by a factor of a. So for my v here, if I wanted to do 3v, so if v looked like this, 3v would look like this, and that the whole thing would be 3v, because it's 3 times as long as the original v.